Hi, my name is Bashi, and today I'm going to go over binary search. So we're going to be given an array of integers called nums, which is sorted in ascending order, and an integer called target. Now we have to look for this target in the nums array. If the target exists, then we return its index. Otherwise, we return -1. We must write the algorithm with type complexity of log n. So which algorithm do we use? Well, binary search, right? It's in the title. So what is binary search? Well, pretend that you had a phone book, right? And the phone book had some pages. Those pages were 0, 1, 2, 3, all the way to page 100, okay? Let's say we're looking for, I don't know, somebody named Sam, right? We're looking for Sam in the phone book. One thing we can do is we can look through this phone book, right? Starting at the very first page. We can look here. Is Sam here? Probably not. We probably have A's, right? Then we go to page 1, then page 2, then page 3. You know, Sam's going to be somewhere right here in the middle, right? A better approach is we can look in the middle of the phone book. What letter do we have here? Let's say we had Q, right? Now, Q comes before S, right? We're looking for Sam. So we don't have to look at this side of the phone book, right? We can essentially just throw this side away. To look here, let's say Q landed on page 50, right? We looked halfway. Now, where do we look? Well, we look on this half, right? We want to look from 51, right? Because we looked at 50 and it wasn't there because it was Q's, all the way to 100. So where do we look now? Again, we can do the same approach. Look in the middle, right? Let's say approximately page 75. Let's say here we got T. Okay, well that means we can just throw this problem away, right? We can throw this side of the problem away. Now we can look in this array here, right? From 51 all the way to 74. And we do the same thing. We look in the middle. Let's say this time we ran into an R. That means we can throw this part away. Let's say that the middle was 63. So now we look at the next one, right? We look at 64 all the way to 74. And we take a look in the middle. Now let's say that this time we found it, right? We found Sam at this page. Let's say that we found it on page 69, right? The middle there. So they want us to return the index. So we return page 69. Now you see that in each step here, we're cutting the problem in half. In every step, we're getting rid of half of the phone book, right? We don't need the other half. We know that it's not there. And that's what a binary search is. For each step, we cut the problem in half. And this works because we have a sorted array. Let's take a look at the examples. So here, our target is 9. All right, so we look in the middle. In this case, we have 2, right? Let's just say that if we have 2 numbers that are in the middle, we just pick the lower bound, right? So let's pick a 3. Let's say this was our middle. Is it here? No, right? Let me write the indexes right above. The index is 0, 1, 2, 3, 4, 5, right? These are essentially our page numbers. It's not here, right? So I can get rid of all this here, right? And I want to look from 3 to 5, right? What's the middle? Well, the middle is 4. So is it in 4? Yes. So we return our page number, right? Because at 4 we have a 9, and that's what we're looking for. So we return the 4. Let's take a look at example 2. In this example, our target is 2. Let me go ahead and write the index numbers. And we look in the middle, right? We said 2 and 3. If there's 2 in the middle, just look at the lower one. We take a look here. Is 2 here? No. But we know that the array is in ascending order, right? So we know that it has to be lower than 3. So we can get rid of all this here, right? Now we just look 0 to 1, right? What's the middle? Well, there's 2 of them. So we look here, right? The lower one. Is 2 here? No, it's not. But 2 is bigger than -1. So I can get rid of all this here, right? And just look here. Right here. We say, hey, there's 1 index left. Is it there? Well, no, it's a 0, right? So it's not there. So they want us to return -1, right? And that's binary search. So let me go ahead and get rid of all this stuff and bring up my code editor. So we're given that array, right, called nums, and we're also given that target. Now, so we have this array called nums, right? We want to search from 0 all the way to whatever the length of this is, right? we need a variable for this, for our left side, and we need a variable for our right side. So let's go ahead and write that. So we will make this an integer, we will call it left, and at the very beginning, right, left is at 0. And we need one for right side, right? So int right is equal to the length of nums, right? Minus 1, right? Because we have to account for the 0, right? So every time we're gonna break the problem in half, right? Break it in half, break it in half, break it in half. We will continue doing that, cutting it in half, while left is less than or equal to right. Right? Because at the very end, right, if we only have one left, well then left equals right, and we have to check that last element. So we keep doing that while this condition is true. So let's write that. So while left is less than or equal to right. Right? We want to continue this, right? We want to check the very middle number. So we have to go take a look in the middle. But how do we get that middle number? Well, I'll create a variable to hold the middle number. But how do we get this? Well, we just add left plus right. Then we divide it by 2, right? 0 plus 100 divided by 2 is 50. Go take a look at 50, right? We say, hey, is our target here? If target is equal to nums of middle, right? We're saying, hey, look in the middle of this array. Does this equal our target? If so, then we found it. We just return the middle, right? Because the middle is the index, and that's the target. That's the index that we want to return. Otherwise, if the target is less than where we're looking, so let's take a look up here. Let's say that this is our middle, right? We look here. This number is, I don't know, let's say 23. We're looking for 20, right? This is our target. If target is less than 23, well then we want to get rid of all this, right? We want to say that we were going to move our right all the way to the middle minus 1, right? So we're going to move this right So if my left was here and my right was here, right? And we look here and it wasn't. So we got left over here and we got left over here. So we would have the left somewhere over here and the right over here, right? We look here, it's not there. So I want to move this right all the way, not to the middle, because we looked in the middle and it wasn't there. I want to go one less in the middle, right? I want to move it one less. So that's why it's middle minus 1, right? So now R comes here and we're going to look between these two. Now, if this is not the case, right? That means that our number falls on the other side. Our number falls here. So instead, I want to move left this way. I want to move left to the middle plus 1, right? I want to look at this spot here. So let's write that. We say else. We want to move left all the way to the middle plus 1. So let's go through it, right? First we get the middle index. Then we say, hey, is my target here at the middle index? If so, if it is, then return it. If it isn't, then we say, hey, is the target smaller than what we are looking for, right? Because remember, this array is in ascending order. If it is, then move the right to the middle minus 1. Otherwise, that means that the target was bigger, right? If this isn't true, then that means that the target is bigger, right? Because if it wasn't the same and it wasn't less, then it's bigger. The target is bigger, so we have to move the left all the way to the middle plus 1 because the target is bigger, so it falls somewhere there. Then it just cycles through again. Adds the left plus the right. It gets the middle, right? All the way until they're less than or equal to. If it finds it, then we return the index. If we get past all that and we did not find it, well, we have to return -1. And that's all the code. I'll leave it up there in case you guys want to see it, but I'm going to copy it. I'm going to bring back LeetCode. I'm going to paste it in. Go ahead and run. Make sure we didn't make any syntax errors. All right, both cases passed. I'm going to go ahead and submit. And it looks like we passed all cases. Let's do the same for Python. All right, I'm going to come here, go to Python, and paste it in. Same thing, we got the left and the right. We do it while left is less than or equal to right. We get the middle. If what we found in the middle equals a target, we'll return the middle index. Otherwise, if target is less, then we move our right to the middle minus 1. Otherwise, we move our left to the middle plus 1. If we exit this while loop and we didn't find it, well then we return -1 just like they asked. So let's go ahead and run. Should we pass test cases? All right, and then we'll go ahead and submit. All right, and looks like we beat all cases as well. And that's it for binary search. If you have any questions, comments, suggestions, leave a comment down below. If you found the video helpful, go ahead and give it a like. And that's it. Thank you very much for your time.